Good morning, class 9 students. I am your maths teacher, and this is the part 2 for the chapter number 1, number system. In this video, we'll cover the irrational numbers. In the last video, we have already seen the rational numbers. What are rational numbers? The numbers which can be expressed in the form of P by Q or ratios are called the rational numbers. And irrational numbers are the numbers which cannot be expressed in the form of P by Q or in the form of ratios. These are the numbers which are non-terminating. They have no end. And non-repeating decimals. They have no end, but they do not repeat also. Okay, so we'll understand this by some of the examples. This is very important to understand the difference between rational and irrational numbers, to recognize the irrational numbers and rational numbers. So let's see some of the examples. 8 1 by 2. 8 1 by 2 can be written as 17 by 2. How? 2 8 is 16 plus 1, that becomes 17 by 2 in the form of P by Q or in the form of ratio. So this is a rational number because it is in the form of ratio. Then say the second example, 0.3333. So this 3 is repeating itself. This is a decimal and it is repeating itself. But irrational numbers are non-repeating decimals. They are the decimals, but they are non-repeating. Here the 3 is repeating itself. We can also write it as 0 decimal point and this 3 raised to this bar. This bar means this 3 is going on and on. This is repeating itself. So yes, it is a rational number. If anything is repeating, decimals are repeating, then it becomes a rational number. Then see the next example, 0.345. If we remove this decimal, we have to put as many zeros in the denominator, as many digits are after the decimal. So this becomes 345 divided by 1000. So this also becomes in the form of P by Q or in the form of ratio. So again, this is a rational number, not the irrational number. Then see, this is root 2. Root 2 is the example of irrational number. How? Now see over here, this series 1.414213563, this is non-terminating. This has no end. So irrational numbers have no end. They do not terminate and they are non-repeating decimals. Unlike see here, 3333 was repeating again and again, but here the digits are not repeating. Has a 4 has repeated over here, but after 1 they are not repeating again and again. So this becomes a irrational number. Similarly, root 3, this is also the value of root 3 is equal to 1.73205080, which is non-terminating and non-repeating. So this becomes a irrational number. Now this pi you have already used to find out various areas, like the area of the circle. There you use pi. So pi is a famous irrational number. How? See this 3.1415926. So this is going on and on. This series is non-terminating and also non-repeating. So this pi becomes a irrational number. Now this irrational number, as we have discussed in the last video, that this irrational numbers are also the real numbers, and real numbers are the numbers that can be shown or represented on the number line. So these irrational numbers can also be expressed on the number line. Let's see how to represent the irrational numbers on the number line. For an example, locate root 2 on the number line. This root 2 is irrational. We have discussed it in the last slide only. So for that we have to understand, we have to consider the Pythagoras theorem. Pythagoras theorem is applicable over the right angle triangle. Right angle triangle. And what does the Pythagoras theorem says? That hypotenuse square is equal to base square and height plus the height square. So here see the base value is 1 and the perpendicular value is also 1. So we have to put it into this formula. This is the right angle triangle. When we put base equal to 1 and height or perpendicular equal to 1, then this becomes hypotenuse is equals to under root of 1 square plus 1 square. This gives you nothing but root 2. Hypotenuse becomes equal to root 2. That is this. Using this Pythagoras theorem only, we will be able to plot the irrational numbers on the number line. Let's see how to plot the irrational numbers on the number line. The first step says to make a number line with 0 as the center and mark points 1 and -1 on the number line. Like you do for the integers, make a number line. Then in step 2, with the same length as between 0 and 1, draw a perpendicular to point 1 such that new line has a length of 1 unit. So from this one you have to draw a perpendicular. Perpendicular means you can use your compass, you can use your D to make a 90-degree angle over here. So this will become a perpendicular over this number line from this point 1. Okay. Now let's see the third step. Now you have to join the point 0 or this point with the new point. This length is 1 unit and you have to join these two. The 0 with this end point over here, end point of this perpendicular. The fourth step says, now let us name the triangle as A, B, C, such that AB is the height. This AB 1 centimeter is the height or the perpendicular, and BC becomes the base of the right angle triangle. So this becomes a right angle triangle, and this A and C becomes the hypotenuse of the right angle triangle. Step 5. Now length of the hypotenuse you have to find out by using this Pythagoras theorem. 1 plus this 1, this becomes under root 2. Okay. Step 6 says taking AC. Now taking A and C, this point is C. Taking AC as the radius and using the compass, extend this point on the number line and mark it as D. So the distance between C and D is nothing but root 2. Hence OD represents the distance root 2. Now let's see another example, that is root 3 on the number line. For drawing root 3, we again consider the Pythagoras theorem. Using the Pythagoras theorem, again hypotenuse square is equal to base square plus height square. This time our right angle triangle is this one, where the base is 1 and root 2 is the height or perpendicular. We'll put these values in this Pythagoras theorem and we'll get the hypotenuse as root 3. So for this you have to see that you already know how to plot this root 2 on the number line. First we'll plot this root 2 on the number line. First we find root 2 and mark it on the number line. Then we find root 3. Let's see how. We have to follow the same steps. First we have to make this number line with 0 as the center, 1 and -1 points on the number line. Second, we have to make the perpendicular from this one point. Okay, and then we have to join this 0 with the end point and name the triangle as ABC. This becomes a right angle triangle. Then using the Pythagoras theorem, the value becomes root 2. The value of AC becomes root 2. Then taking this as the radius, we have to extend the point to the number line, that is till D. So the CD length is root 2. After this, now we need to construct a line which is perpendicular to the line AB from point A. Now from here we'll draw a perpendicular line from point A to E, that is also 1 centimeter long. Okay, this we have already made, and here we are making a perpendicular 1 centimeter long. After that, now join the points C and E. When we join these 2 points, this again becomes a right angle triangle with the base 1 perpendicular root 2, and we can apply the Pythagoras theorem to find out the length of OE, that is nothing but root 3. Now then extend the point E with the compass taking the radius CE. Okay, now you have to take this as the radius, that is root 3. This is point CE, and now you have to extend this E onto the number line. This point becomes F. Now this length CF becomes root 3. This is how you have to plot the irrational numbers on the number line. If you have any doubt, you can go back and watch the video again. Based on this, you have to solve the assignment. This is question number 1. Identify the rational irrational numbers, and question number 2. Represent the following irrational numbers on the number line, root 5 and root 7. Hope you enjoyed the video. Thank you for now. We'll continue the chapter in the next video.